Okay, we're going to start off with a quick review of factoring. So on question number 1, first thing I noticed is that they all have variables with them. So I know I'm going to have a greatest common factor of x squared, and they are all divisible by 2. So my GCF is going to be 2x squared, and then that's going to be 12x squared plus 5x minus 2. Okay, and then I'm going to go ahead and factor those two parentheses. So 4x, 3x, 2, and 1. We want it to be a plus 5x in the middle, so I'm going to do positive 8x minus 3, and that will give me 5x in the middle. Okay, on question number 2, I can tell once again they've all got variables, so I'm going to have a GCF of x to the third. I noticed that the leading term is negative. We really want that leading term to be positive. A lot of the rules that we teach you in different things, they work when the leading coefficient is positive. So instead of using a GCF of a positive 3x to the third, I'm going to use a negative 3x to the third. So negative 3x to the third. And then that's going to leave me with 2x squared minus 1. Okay, so 2x squared minus 1 is the difference of squares. 2 is not a perfect square number, but we can factor that if we use the negative, or excuse me, if we use the square root of 2. So square root of 2x plus 1 times the square root of 2x minus 1. All right, question number 3. I was kind of hoping there'd be a greatest common factor of 3, but 3 doesn't go into 26, so looks like no GCF, so we're going to have to do factor pairs. I could do 1 and 15, or 3 and 5, and 1 and 21, and 3 and 7. So I think I'll try the 3 and the 5 and the 3 and the 7. So 3x, 5x. And I'll put the 7 with the 5. That'll give me 35. And I'll put the 3 over here. So 3 times 3 will give me 9. So I want a positive 26. So a positive 35 subtract a negative 9 would give me a positive 26. So that factors to 3x plus 7 times 7x minus 3. Okay, number 4 is sum of cubes. 27 is a perfect cube, x to the third is a perfect cube, and 125 is a perfect cube. So we're going to take the cubed root of all 3 of those terms so that we can get our first parentheses. So cubed root of 27 is 3. Cubed root of x to the third is x, plus, the sign stays the same, and then the cubed root of 125 is 5. Okay, now we have our other parenthesis. And so basically, I'm going to try to do the first and the last term and then the middle term. So 3x times what is 27x to the third? That would be 9x squared. And then 5 times what is 125? That would be 25. And then to get the middle term, I just multiply these two together. So that's 15x. And then you have to fix your signs. So if the first sign is positive in the first parenthesis, then this sign has to be negative because they've got to be opposite. And then it always ends in a positive. So that's what that one factors to. Okay, and then number 5 is also difference, or yeah, difference of cubes. 8's a perfect cube, x to the third is a perfect cube, 64 is a perfect cube, and y to the third is a perfect cube. But this one's a little different because it also has a GCF of 8. So I'm going to take the 8 out first. That's going to leave me with x to the third minus 8y to the third. These are still perfect cubes. X to the third is a perfect cube, negative 8's a perfect cube, y to the third's a perfect cube. So we'll go ahead and take the cube root of those. Cube root of x to the third is x. Subtract, cube root of 8 is 2. Cube root of y to the third is y. So that's my first parenthesis. So my second parenthesis, x times what is x to the third? That would be x squared. Negative 2y times what is going to give me minus 8y to the third? That's going to be 4y squared. So remember, we got to fix our signs. So x times 2y is going to be 2xy in the middle. Signs are opposite and then always positive. So we've got 4y, so negative 2y, x minus 2y, and then x squared plus 2xy plus 4y squared for the other parenthesis. And then you have your GCF of 8 out in front. All right, so that's a review of factoring. So today we're going to do systems of 3 equations with 3 variables. So in the past, when we've been doing our solving our systems, last time's lesson, we would get an ordered pair. So we would get a solution with x comma y or no solution or infinite solution. Today, we're going to be working with planes, and so we're going to have three. We're going to have what's called an ordered triple, and so we're going to have three variables. So we're going to have x, y, and z for our solutions. So when we this next part of the slide kind of shows you visuals of what is going to happen. So when you take these three planes and you show that they intersect um, in one point, that would be right here where all 3 points intersect. So that's where we get exactly one solution. That's where you get the ordered triple, x comma y comma z. Infinitely many solutions would be this picture over here on the right where all three of these planes intersect in a line right there. And so that's going to give you infinitely many solutions. And then the no solution scenarios, there's three shown here. They're no solution because you have to have all three planes intersecting each other at the same time. And the one on the right doesn't even intersect at all, but the other two on the left, they only intersect two planes at a time, so not all three at once. So that's a no solution. So we could have 1 point, we could have infinitely many, or we could have no solution, just like we did with two variables. Okay, so here we go. Here's our system of three variables. So I've got x, y, z. For however many variables you're going to solve, you need that many equations. So if I've got x, y, z, then I need to have three equations. To begin with, you've got to decide on what variable you want to eliminate. So you kind of look at the whole problem to begin with, just quick glance at all three equations, all three variables, and then just make a decision based on the numbers, what variable would be the easiest to eliminate. So for me, looking at this problem, I would not eliminate z. I would not choose z because there are no multiples in z, 3, 5, 4. There's no multiples, so I know I'm going to have to multiply each equation. So I would narrow it down to x and y. I mean, there is no right or wrong. I just try to choose whatever I think is going to be easiest. So I feel like I'm just going to eliminate x's. If I use the middle equation, I think I could, those are multiples, 4, 2, and 6. 2, 4 is a multiple of 2, and 6 is a multiple of 2. So I think I could eliminate the x's pretty easy. So once you make your decision, it doesn't matter, like I said, what variable, but once you make your decision, don't change your mind. You have to stay with that variable for a little while. So we're going to start off by eliminating our x's. So I've got to use two equations, so I think I'll just use the top two. So we're eliminating x's. The top equation is a 4x. The bottom equation is a 2x. Those need to be opposite numbers. So I will multiply the bottom equation by -2. So I'm not going to do anything to the top equation. I'm going to write it just the way it is. And now I'm going to take the bottom equation and I'm going to multiply it, or I guess it would be middle equation right here. It's going to be bottom down here in my system, but the middle equation. So I'm going to multiply this whole equation right here by -2. Both parts, both sides, okay? Multiplying by -2. All right, so -2 times 2 is -4x. -2 times a -3 is plus 6y. And -2 times 5 is -10z. And -14 times 2 is plus 28. Okay, and now I've got it set up so that the x's will eliminate. So I'm going to add those two together. The x's do eliminate. 2 plus 6 is 8y. And then 3 plus a -10 is -7z. And 1 plus a 28 is 29. Okay, I'm going to put a star by that equation. I'm going to come back to it in a minute. I'm going to put a star by that one. Okay, so now we're going to go back to our three original equations. We need to use all three. So I've used the top two. So that means I have to use, I don't have a choice, I have to use the bottom equation. I've used the top two, so I got to use the bottom. Now you're going to have to overlap, so I'm going to use the bottom equation, and you can pick either one of the top two to choose to work with again. So I'll just do the middle equation. Okay, so we'll do middle and bottom. So once again, we're not changing variables. We're looking to eliminate x. So in this equation, the middle equation is a positive 2x, and the bottom one is a positive 6x. I want them to be opposite, so I want the middle equation to be a -6x. So I'm going to multiply this whole thing, both sides, by -3. That will give me a -6x. So -3 times 2 is a -6x. -3 times -3 is plus 9y. -3 times -5 is -15z. And -14 times -3 is positive 42. Okay, and now the bottom equation, I'm not going to do anything with that one. I'm going to write that as 6x minus y plus 4z equals -1. Now remember, we're eliminating y's, or excuse me, x's, sorry. We're eliminating x's. Don't change the variable. So here we're eliminating those x's. So 9 plus -1 is 8y. -15 plus +4 is -11z. And 42 plus a -1 is positive 41. And I'm going to put a star by that. Okay, so what we've done is we've taken our system with 3 equations, 3 variables, and we have now reduced it down to 2 variables and 2 equations. Those are our start equations. So that's what we want to do. We want to get it down. We want to keep reducing it until we get it down to 1 equation, 1 variable. So now I'm going to take my 2 start equations and decide what variable to eliminate. So it looks like to me y would be an easy one to eliminate. I've got a positive 8y in both of those equations, so if I multiplied one of them by a negative, they would be opposite. So I'll take this 8y minus 7z equals 29, and then I'll take the bottom equation and multiply it by -1. So -8y plus 11z equals -41. Okay, let's add those two together. And so the positive 8y and -8y are opposites, so we know those are going to add to 0. So this piece is 0, and then -7 plus positive 11 is 4z, and 29 plus a -41 is a -12. Divide both sides by 4, and so z equals -3. So in our solution set, our triple, we know that z is -3. We just need to figure out what x and y are. Now, it wouldn't make sense to go clear back to the beginning because I have too many variables, too many unknowns. So take the -3 and now go backwards and put it into an equation that only has 2 variables. So I think I'll just use this equation right here. Okay, so I'm going to put -3 in for z, so that's going to be 8y minus 11 times -3 equals 41. All right, so keep working on that. So 8y plus 33 equals 41. Subtract the 33, so 8y equals 8. So that means y equals 1. Okay, so I'm going to put 1 right there. And now I'm going to take both of these answers, 1 and -3, and go back to an equation with 3 variables and solve it for x. So I think I'll just go and you put it in the top one. That'll probably be the easiest to show the substitution. So y is 1 and z is -3. So I'm going to put a 1 right here and a -3 right here. And now we're going to figure out what x is. Okay, so 4x plus 2 minus 9. So that's going to be 4x minus 7 equals 1. We're going to add the 7, and we're going to get 4x equals 8, and then divide by 4, so x is 2. So we have our ordered triple right here. 2, 1, -3. Now, you could take, if you wanted to make sure you did it right, you could take the 2, 1, -3, and you could substitute it into maybe a different equation, maybe this equation right here, and see if that's a true statement. If it is, then you know you have the right answer. Because if it's a solution, it should be true in any one of those 3 equations. Well, it has to be true in all 3 of the equations, but you could check it in any one of them if you wanted. Okay, let's try it again. So when I look at this one I feel like I could probably eliminate x's, y's, or z's. They all look pretty easy to me. We did x's last time, so we'll just change it up and we will eliminate y's this time. Okay, so we're going to eliminate y. All right, so I'm going to take the first two equations and eliminate y. Lucky for me, they are already opposite, negative y, positive y. I can just add those two equations together just the way they are. I don't even have to do any work. So 4 plus 1 is 5, so 5x. Negative 1y, positive 1y is 0. 3z plus 1z is 4z equals 13 plus 2, which is 15. I'm going to put a star by that because that's my start equation. And now remember, I have to use the third equation, the equation I haven't used. So I need to use this one, and I need to match it with another equation. Since I'm eliminating y's, I think I will go with the middle equation. Seems like those numbers are smaller. So if the bottom equation is a plus 3y, we want this one to be a negative 3y. So to do that, we're going to have to multiply everything by a negative 3 on the middle equation. This one's got to go by negative 3. Okay, so my x plus 3y minus 2z equals negative 17 is staying the same. I'm not doing anything with that. Negative 3 times x is negative 3x. Negative 3 times y is negative 3y. Negative 3 times z is negative 3z. And negative 3 times 2 is negative 6. Okay, we can combine those two together. And when we do that, we end up with the y's eliminating, which we want to have happen. Negative 2x minus 5z equals negative 23. There's our second start equation. So now we've got x's and z's in both of those equations. So now we've got to decide which variable we want to eliminate. Doesn't seem like either one of them is very easy. So it looks like we're going to have to multiply both equations. So I guess I'm going to go ahead and I'll just eliminate the x's. So I've got a 5x and a negative 2x. So I think I'm going to change them both to be 10x's. So one a positive 10x and one a negative 10x. So first equation, I'm going to multiply by 2. So I'm doing my start equations now. So 5 times 2 is 10x. 4 times 2 is 8z. And 15 times 2 is 30. And the bottom equation, I'm going to, over here, the one on the right, which is going to be my bottom equation, I'm going to multiply that by 5. So negative 10x minus 25z equals a negative 23 times 5, a negative 115. Okay, so let's go ahead and add those two together. That will eliminate our x's. And we're left with negative 17z equals negative 85. Okay, and now we're going to divide both sides by negative 17. So that's going to turn out to be 5. So z is 5. All right, so our triple here, we know z is 5. And I'm going to substitute it. I think I'll substitute it into this equation right here, over here on the left. So 5x plus 4 times 5 equals 15. So 4 times 5 is 20. And then if you subtract 20 to the other side, it'll be negative 5. So you end up with 5x equals negative 5. So x equals negative 1. And now I'll go back to the beginning and put negative 1 and 5 in. So let's see. I think I will put it, I'm looking for letter y. So I think I'll put it in the middle equation. So negative 1 plus 0, or excuse me, we're keeping that as a y. Plus 5 equals 2. Okay, so y plus 4 equals 2, so y equals negative 2. Okay, so once again, we'll try this one. So we've got x, y's, and z. So I think we've eliminated x's and y's, so why not try z's? This one, it looks like z would be okay to use. Once again, I feel like I probably wouldn't choose x. I would probably do y's or z's, so we'll try z this time. So we're going to eliminate z. So right off the bat, I noticed that the top equation and the bottom equation, the z's are opposite. So I think I will just add those two together right off the bat. So negative 3x plus positive 4x is x. A positive y and a positive 2y is 3y. A negative z and a positive z is 0. And negative 2 and a positive 1 is negative 1. Okay, so there's my first start equation. And now I'm going to do, I have to use the second equation right here because this is the one I haven't used before. So I'm going to do this one. And I think I'm going to combine it with the bottom one. And I'm going to, remember, we're still eliminating z's. So I have a negative 2z in the middle equation. So I want the bottom equation to be a positive 2z. So 2x minus y minus 2z equals negative 12. And now I'm going to multiply everything by 2 on the bottom equation because we're eliminating the z, so we're going to multiply everything by 2. So 8x plus 4y plus 2z equals 2. So add those together, 10x plus 3y, the z's add to 0, equals negative 10. So there's my second start equation. So I feel like now I'd probably want to eliminate the y's because I've got positive 3y in both of them. So I will take this equation on the left, multiply it by negative 1. So that's going to be a negative x minus 3y equals positive 1. And I'm going to add 10x plus 3y equals negative 10. So I'm going to add those together. That's going to give me 9x equals negative 9. So x is going to be negative 1. Okay, so negative 1, comma. So I think I'll just put it back here. So negative 1 right here. So if I add that to the other side, I'm going to get 0. So 3y equals 0, and 0 divided by 3 is just still 0. So y is 0. And then I will put those, I'm looking for z, so I think I'll put it in the bottom equation. So I'm going to go 4 times negative 1 plus 2 times 0 plus z equals 1. So this is going to be negative 4 plus z equals 1. So add 4 and z will turn out to be 5. So there's our triple. So you don't always get an ordered triple. You can get a no solution or an infinite solution. What happens in those scenarios is the variables will all drop out. And if you end up with a true statement, when the variables all drop out, if you end up with a true statement, then it's infinite solutions. If the variables all drop out and you end up with a false statement, then it's a no solution. So that's just kind of how you tell if it's going to be infinite or no solution. Okay, so this one, once again, I've got 3 different variables and 3 equations. I do notice, though, that the third equation only has 2 variables in it. That's good because, remember, our goal is we're trying to get it down to 2 equations, 2 variables. I've already got one of my start equations, so to speak, because that one's our 2x plus z. And since I have to use all 3 equations, I'm going to use these top 2. Now, I don't have a choice what to eliminate. I have to eliminate the y's. If our start equation only has x's and z's in it, then I need to eliminate the letter y from the first 2 equations so that my other start equation only has x's and z's. So even if y is not the easiest number to eliminate, you have to eliminate y. So we want a second equation that only has x's and z's in it. So we're going to eliminate y. So I think I'm going to multiply this top equation right here by negative 2. Okay, so if I do that, I'm going to end up with negative 4x minus 2y plus 2z equals positive 2. And then the other equation is x plus 2y plus 2z equals 10. Okay, combine those together and the y's drop out and we've got negative 3x plus 4z equals 12. Okay, so here's my second start equation and we've got to decide, now do we want to eliminate the x's or the z's? And I think I'll choose z. So now I'm going to use the two start equations. So since this equation on the right has a positive 4z, I want the equation on the left to have a negative 4z. So I'm going to multiply this whole equation right here by negative 4. So that's going to give me negative 8x minus 4z equals negative 12. And then my other equation I'm not changing. So negative 11x plus 4z equals positive 12. So we'll add those together and we end up with negative 11x equals 0. So once again, we're going to end up with x equals 0. 0 divided by negative 11 is 0. Okay, so now we'll back substitute. So I think that, so this is 0. I think I'll put 0 into this equation up here on the left. So I'll put 0 right here for x. So this will be 2 times 0 plus z equals 3. So that means z is 3. I'm using the original equation, not the multiplied by 4. So z is 3 here. So when I'm back substituting, I go back to the original equation. So I would do just the 2x plus z equals 3. That's what I would substitute into. Okay, now I'm going to take the 0 and the 3, and it doesn't really matter what equation I put it into. So I think I'll go to the top one because the y is positive. So 2 times 0 plus y minus z, and z is 3, equals negative 1. So 2 times 0 is 0. And then if I add the 3 to the other side, I end up with 2. So y is 2. So there's our ordered triple on that one. Okay, so this one, I'm looking at it. Now I've got two variables, but I've got three different variables total, with each equation only having two variables in them. And I have three equations. So this one's doable. I do notice something interesting about the third equation. It's 8x plus 8z equals negative 48. I feel like since they're all divisible by 8, I'm going to go ahead and do that and make that a smaller number. Remember, I always like to keep my numbers small if I can. Just helps with my mental math. So this is true. They're all going to reduce by 7. You could divide them all by, 8. I was writing the number 7 and messed the whole thing up. So we're going to just take that third equation and divide them all by 8. So this will end up being x plus z equals negative 6. So I'm going to use those green equations. They're smaller numbers, and they're equivalent. So that's an option. You could divide by a number. Typically we multiply, but you could divide by a number if you wanted. So I feel like I need a start equation. So I don't know that it really matters which one I choose as my start equation. So I think I will just make the top one my start equation. Okay, and so that one has x's and y's in it. So that means between these two equations right here, I need to eliminate the z's. So if I do that, I'm going to multiply the bottom equation by 7. So I'm going to have y minus 7z equals 50. And then I'm going to multiply the bottom equation by 7. So 7x plus 7z equals negative 42. Okay, so now we'll just go ahead and add those together. We get 8. Wait a minute. What was I eliminating here? Okay, I am eliminating the z's, but this is y plus 7x. Those aren't going to add together. So this is going to be 7x plus y equals 8. So there's my second start equation. But that looks very similar to my first start equation. 7x plus y equals 8. So if I subtract those, I'm going to end up with 0 equals 0. And 0 equals 0 is a true statement. So since it's a true statement, I know my answer is infinite solutions. Okay, once again, this one right here, I've got x plus y minus 5z equals -5, and then y minus 2z equals 14, and then 4y plus 2z equals 8. These two equations right here have the same variables, and they're opposites, so I feel like I'm going to eliminate z. So if I do that, I'm going to end up with 5y equals 22. And then we're going to divide by 5, so y equals 22 over 5. So this one's going to have a fraction for an answer. So we've got 22 over 5 for y. Now we just got to figure out what x and z are. Okay, so now I need to figure out what my other two variables are. So I'm going to go back to one of my two equations, and I'm going to put my y in, and that will tell me z. So I think I will just put it in, it doesn't matter. I think I'll put it in the bottom equation. So I'm going to go 4 times 22 over 5 plus 2z equals 8. Well, 4 times 22 over 5 is 88 over 5 plus 2z equals 8. And now I'm going to subtract the 88 over 5. So 2z equals 8 minus 88 over 5. So if you get a common denominator on that, that would be 40 over 5. So we would end up with 2z equals a negative 48 over 5. And then we're going to divide by 2, and since there's already a fraction there, you're going to end up with negative 48 over 10. That's what z is. And that fraction will reduce to negative 24 over 5. Okay, so there's z. And then the last one. So we're going to have to put in the y and the z to find the x. So this is going to go x plus 22 over 5 minus 5 times a negative 24 over 5 equals negative 5. Okay, so this right here is going to be x plus 22 over 5. And then a negative 5 times a negative 24 over 5 is a plus 24. And that's going to equal a negative 5. We're going to subtract the 24 since it's just an integer. And that's going to give me x plus 22 over 5 equals negative 29. Okay, so now I'm going to move the 22 over 5. So negative 22 over 5 minus 29. So if you get a common denominator there of 5, so 29 times 5 is a negative 145. So now you've got a negative 145 over 5, and you're adding that to our negative 22. So our answer is going to be negative 167 over 5. So that one was a little hard with the fractions. So the key to this, guys, the algebra is not hard because basically you're just multiplying equations by a number, but it's really easy to lose a negative sign or, multiply wrong if you're not careful, or, just try to keep yourself organized and just go slow enough that, you're being careful, fast enough that it doesn't take you forever to do the problems. Just find a nice, happy pace. Don't go too fast. Don't go too slow. Just being careful. And I think that you'll find great success with these. They're not too bad as far as the math portion because it's always the same kind of setup. You always start with 3 equations, try to get it down to 2 equations, and then 1 equation with 1 variable. Okay, good luck.